system which is going to support the physician or clinician to understand the problem in a more detailed way than a conventional method. So at present moment, if you look at everywhere, all over the world, AI systems are doing a fantastic job in healthcare sector. And however, in still at the infancy state, I can say, because mostly we rely AI on primary care. And nowadays only due to the advancement of deep learning and machine learning and AI, different methods, we are moving on to a very complex application like surgery, robotic surgery, and so on. And when you look at the advantages, usually if you talk about AI, we always need to talk about data, because without data, there is no need of AI. So how do you get the data? Especially in healthcare industry, getting a data is not at all an easy job. It's become a very, very tedious and highly a challenging task to collect any application specific data in a clinical environment. If you are looking at a normal application, you could do by using a simple sensors. But whenever we come to a healthcare, we have to be very cautious. We have to be very serious on ethical issue. We have to be very serious on the system that should not affect the human being at all at any point of time. However, the recent innovation in the wearable sensor, which is very cost effective and also very efficient and very simple sensors, are highly useful for many applications that generate a huge volume of data. So these data helps the AI researcher to develop a novel algorithm, and they can easily test and benchmark the algorithm with the existing data sets. And also, it is very interesting to see over the recent year that people are trying to share the databases. So in clinical application, there are huge number of data sets are now available, where those are all open source data sets, and those data sets are collected by the particular research group in that country, and they are made it as an open source where any researcher who are interested in that field can utilize the data for the application. So in this particular slide, what I would like to convey as just a suggestion to all the people here, so we always say that it is very difficult to get data. Nobody is sharing a data. So usually if you go and approach anyone, it's not easy to share any data all of a sudden, because they don't know who are you and what is your background.
Starting from the first location, first the task is setting the configuration of the initial, configuration and the goal state, and there must be a guiding function. Most of the researchers, they use a heuristic function to guide the search. That gives better result. So the heuristic function acts like a guiding function for the search process. So it starts from a particular state and then test whether there is a dirt or it is clean. We can assume that there are a number of squares in the room. So each square has to be checked whether there is a dirt or not. So if there is dirt, it has to be clean, otherwise it has to move out. So the process should be repeated until it reaches to the goal state. So this is one of the example. So to show how to make you to understand how AI is used. So we build intelligence, human intelligence into the machine. So sometimes people talk about AI agent. So AI agent means it is built with intelligence capability. Means we import the capability of the human being. We make the machine to do the right thing at the right time. There are different types of agent. We have goal-based agent, and then simple reflex agent, model-based agent, utility agent. There are 5 classes of agent actually. So when we are trying to do research to solve a particular problem, we have to decide the environment, analyze the properties of environment, also decide what type of agent program you are going to design. Simple reflex agent works based on the current person, and then it does not make use of the past knowledge.
Sir, whether you are going to change the slide, sir, changing the slide, sir?
Yeah, I'm changing, sir. I'm changing.
It is
and
not
so yeah, now it is changed, right?
No, yes, sir. It has changed. Thank you, sir.
So for medical applications, for example, if a robo is designed to monitor the patient, or if a chatbot is deployed in a computer system or in a mobile of a patient, then it has to detect the disease periodically, monitor the condition of the patient. Then it should help the clinicians and patient also to interact with each other. So one of the popular application is a chatbot. So that builds that bridges the gap between communication gap between the peoples involved in the environment. So for example, in hospital, nurses, then doctors, and then patients, attenders, all people will be there. So all of them needs help to communicate with each other at certain point of time. So due to busy schedule, one or other person may not be available. So the chatbot can help them to communicate with each other, share necessary information, timely information. It will help the patient to recover fast. Also, it will help the doctor to make the decision more efficiently. So disease detection enables early detection of diseases and also treatment of pathological conditions of patient. It, for example, for heart disease, the symptoms are given. It will be able to, in real time, we can observe the symptoms. Those are like sensors. Sensors sensors are input devices used to collect the inputs from environment. So the symptoms in AI system will be considered as an input, which are called percept. In AI, we call this as percept. If there are a set of input, then it forms a sequence. We call this as percept sequence. So after detecting the symptoms for given symptoms, it is going to analyze and perform an action. If there is a severe cold, fever, so we know that when COVID-19 started and when it was started in 2020, so there were 15 million plus people were affected by COVID, and there were huge demand for oxygen cylinders, and also there was a huge demand for medicines, and also other necessary basic needs for the peoples. So all these things can be solved by having a AI-based system.
One side, we were all breaking our head. Other side, people started understanding this problem and they came out with networks which resembles our brain. So to the brain, we are not feeding these features, right? So like it recognizes the face. And to recognize the face, we are not giving the brain the iris diameter or the distance between the two eyebrows and all that. Instead, it just looks at the face and then it performs feature extraction, it compares with its database, and then it comes out with a better result. And moreover, like fine, we are born as a soft brain people, which means that our environment, our society, and then what we read and how we live, it basically defines the connections in our neural network. But still, as a child, we are not taught to classify the different types of cars, to classify the different types of lorries, to classify the different types of bicycles. So, like we may learn, like, classifying different types of cars. Having understood the classification of different types of cars, our brain automatically performs the classification of different types of lorries, different types of cycles, which means initially, like when we are doing research for classifying any network, half of it should be used for training, half of it should be used for testing. But then we later on, like researchers understood, human brain uses something called transfer learning, which means it is trained with some data set, but it uses those ideas, it generates the features, and then it performs a better classification for entirely different set of images. So why can't we capture the idea of transfer learning? And again, fine, brain too identifies a particular person only by extracting the features, right? But it does it internally, which means in brain, we should have some levels or some layers of neurons which are performing feature extraction. Then the other layer of neurons may be involved in classification. So They just analyzed and then they came out with a concept like, why can't we have a neural network which performs feature extraction, and at the same time with those features, why can't it perform classification? And this idea resulted in something called deep learning neural networks. So now basically it's a neural network like our human brain. It is to be trained, but the only thing is it has the advantage of transfer learning. We can train it for some things with an entirely different data set, and then you can ask it to classify a different data set, it does it. So that is how deep learning neural networks came into existence. And by deep learning, why do they call it as deep learning? The number of layers, if you see, it's really in the order of 120, 150, and so on. So usually for VPN, we will have 5-layered network, 6-layered network. That's how we would have learned it. But now they are talking in the order of 100, 150, and so on. So therefore, they correctly called it as deep learning because the depth of the network is large. Okay, fine. So now in this presentation, if we see, like we will be having an overview of one-dimensional and two-dimensional networks, and then how these networks work for brain tumor classification and breast cancer classification. Actually, as I have input
resources, it is abundantly available in seaweeds, plant, fungi, microorganisms. So all the areas are yet to be covered by me. So most of the research conducted by me is on green synthesis of nanomaterials, which we can use it as a smart material for biomedical, different biomedical application. Example, tissue engineering, tissue regeneration, bone replacement, dental implant applications, and other medical textile applications also. So if anybody is interested in this area, you can contact us for more protocols and everything. So I just brief about the researches which is being done in the last 10 years. So mostly the biomedical applications of smart materials. So I think as all the faculties, the senior faculties, you are all well aware of the smart materials. So smart materials may be a nanomaterial or engineered nanomaterial for desired applications like biomedical field or electronic field or different automobile applications. So I have chosen natural resources to synthesize smart materials. So smart materials, in the sense, I have used polymeric nanocomposites, metal and metal oxide nanocomposites, and carbon-based materials also. So how can we use these kinds of smart materials which are isolated from natural resources for different applications? So my slides are mostly covering the area of applications where and all we can employ these kind of nanomaterials in biomedical field. So since marine resources, marine environment providing large surface area, they are rich in seaweeds. So they are all rich sources of polymers. So marine polymers like chitosan, sodium alginate, agar, agarose, these are all very much important in biomedical field, especially producing tissue scaffolds. So nowadays they are using 3D printing also. So why we are focusing on marine seaweeds apart from conventional or synthetic chemicals? Why we are concentrating on marine resources? Due to the low cost and surplus accessibility of resources. So some of the medically important marine resources are, so because many seaweeds are giving anti-cancer potentials. For example, carrageenan is a group of compounds which is giving anti-cancer potentiality against different cancers. So similarly, fucoidins and alginate based polymers, so they are all very much important in tissue engineering applications. So especially scaffold preparation. So while studying the in vitro culture of different tissue scaffolds before exploiting into the real-time applications, so we can use tissue scaffolds for testing how the artificial organs and artificial
institution. This is a central library of NIT Silchar campus. And this foundation stone was laid by our former president, Dr. APJ Abdul Kalam. And when he was passed away, this institution has changed the central library name into Bharat Ratna, Dr. APJ Abdul Kalam Learning Resource Center. This is the front portion of this particular building, and this is one of the largest library in South Asia. It is the front portion of this library. And the last slide, maybe the history which I like to share with you. This is the department where I've been working, Electronics and Communication Engineering. Basically, this department is offering 3 degrees. One is the BTech in Electronics and Communication, and this department is offering 2 postgraduate program. One is Communication and Signal Processing Engineering and Microelectronics and Very Large Scale Integration. And finally, this department is offering the PhD degree in all the specialization of electronics and communication, and also the interdisciplinary area of research. So this is the, like the the historical information which I like to share with you all audience. Yeah. So getting into the topic of the today lectures. Maybe it's not a lecture, maybe the discussion, because all are almost the faculty and the teacher, those who are working in the engineering institution. So basically this particular topic, the organizer given to me, advances in medical imaging, but if you look into the, this topic, advances in medical imaging, it will be a very broad topic, right? Advances in medical imaging. So we have a lot of advances, but this 2 hours time is not enough to talk these advances. And of course, I'm not going to talk about all the advances of medical imaging, but rather I'm going to talking about where or which problem specifically I have been working in the medical imaging. Okay, so because it is a very broad area of research, and of course the one researcher, it is not one researcher can't able to do it all these the generalized medical imaging techniques. So in that particular perspective, suppose many of them are teacher, but are not very highlighted in this very fundamental, because if those who are very new in medical imaging, so basically they have to understand what is medical imaging. Generally, how we can able to define the medical imaging, it is a process or technique or creating the visual representation of the human body. Say in a very, in an understanding way, suppose if there is some pain in my hand, so what I have to do, I have to fix myself, otherwise I have to consult the doctor. Okay, so if in terms of consultation, I have to consult the ortho doctors, right? So what ortho doctor will suggest, basically will acquire an X-ray image, right? So what X-ray image is doing, what we can analyze from the X-ray image, the whole visual representation of the body or the place where we have been taken the acquisition, right? So generally this X-ray imaging help us, the medical practitioners, what happened inside. That's why it is given the term interior of the human body, right? So for what purpose? Maybe for the clinical analysis or maybe the medical intervention. Okay. So it's very simple. The medical imaging is nothing but the process which help to create the visual representation of the human body, right? Very simple. But here what we are talking about, this example of X-ray is like one of the medical imaging type, right? But in a generic medical imaging,
the image component. Image component is a pixel. An element of the digital image is called pixel, and there is a correlationship between the pixels, neighbors of pixel, distance measures, connectivity, adjacency. So if we take 4 neighbors of pixel, The yellow circle pixel is a central pixel represented by P, and this pixel has two horizontal neighbors and two vertical neighbors, and this set of pixels are called four neighbors of pixel P, which is denoted by N4 of P. And similarly, diagonal neighbors of pixel P means the pixel P has set of four diagonal neighbors, x minus 1 comma y minus 1, x plus 1 comma y plus 1, etc. 8 neighbors of pixel P. This pixel P has four diagonal neighbors and two horizontal neighbors, two vertical neighbors. And second one is the connectivity. Actually, what is the importance of connectivity? So connectivity means, let us take two pixels P and Q. These two pixels are connected only if they are neighbors and they have same gray values. The connectivity used to determine the boundary of any object. And this connectivity also classified into three categories: 4 connectivity, 8 connectivity, M connectivity. So if we take 4 connectivity, taken two pixels P and Q, in any set C, they are 4 connectivity only if Q is in N4 of P, 4 neighbors of pixel P. Then it is called as a 4 connectivity. Similarly, you can define 8 connectivity, M connectivity. Distance measures. There are various distance measures: Euclidean distance, D4 distance, D8 distance. So if we take Euclidean distance, we have to determine the distance between the two pixels P and Q at a spatial coordinate x comma y s comma t, using this formula: square root of x minus s whole square plus y minus t square. D4 distance also called as city block distance. So the distance between the two pixels is calculated by modulus of x minus 1 plus modulus of y minus t. D8 distance also called as chessboard distance. Calculate the distance between the two pixels P and Q by using this formula: maximum of modulus of x minus s comma y minus t. Adjacency. So the adjacency also classified into three categories: 4 adjacency, 8 adjacency, M adjacency. Two pixels P and
my session, I will just show you two videos where we can actually understand the positivity as well as the negativity which is being imparted in medicine due to AI, innovation, R&D, design and development. முதல்ல எது பார்க்கலாம், பிளஸ் மைனஸ்? மைனஸே ஃபர்ஸ்ட் பார்த்துடலாம். அப்பதான் நம்ம ஆரம்பிக்கும் போது பாசிட்டிவ் ஆரம்பிக்கும்.
A day after Central Gujarat's biggest public hospital witnessed a fire inside the intensive care unit of the COVID hospital, CCTV footage of the incident emerged on Wednesday, revealing that the fire was not from a short circuit, but because of a ventilator placed inside the ICU-1 unit located on the first floor of the SSG building. The footage, which was widely in circulation, clearly shows that there was a kind of blast inside the ventilator, after which the fire started, resulting in panic among the staff and patients present inside the ICU. The CCTV footage shows how the staffers bravely rescued the patients one by one, even as fire had started spreading inside the unit. It is a possibility that the ventilator caught fire due to heating, but the exact reason can be known only after the forensic investigation is done. Forensic experts' help has been sought for the same. The Casualty or Trauma Center of the SSG hospital, which houses the COVID-19 hospital, had provisional no objection certificate of Vadodara Fire and Emergency Services, as the firefighting equipment was intact and in working conditions. Officials maintained that a 4-member committee is probing the reasons behind the fire.
ventilators, நிறைய innovations, நிறைய பேர் நிறைய ventilators கொண்டு வந்தாங்க. If someone cannot understand my language, Tamil தெரியலனா you can please stop me. In between I will be using both the languages. So அந்த innovation என்ன ஆச்சு அப்படினா we were able to save many lives. Obviously we were able to save many lives, but in turn because of this we lost many lives. அதெல்லாம் போடாம இருந்தாலே அவன் உழைச்சிருப்பான். Even without a ventilator he would have survived. But unfortunately the use of ventilator which we had designed has killed many people also, which truly we have to accept. But does that mean அப்ப innovate பண்ணாம வந்துடலாமா? Time testing இருந்தாதான் we can use in healthcare. அப்படினா how do we time test? We have to innovate, we have to implement, and then only we can go for time testing. அப்ப implement பண்ணாதே time testing பண்ண முடியும். அப்ப implement பண்றதுக்கு என்ன பண்ணலாம்? We have to take risks. But after what kind of validation we have to take risks? That we will be seeing in our presentations. So this is a positive note where நம்ம இப்ப சொல்றோம் AI in medicine. The initial startup of AI in healthcare in India எப்ப ஆரம்பிச்சிருக்கும்னு நினைக்கிறீங்க? Healthcare in Indiaல artificial intelligence உடைய impact usage எப்ப இருந்திருக்கும்னு நினைக்கிறீங்க? ரஃபா 2000 வேறதா guess? 5 years back. Almost 1970s 80s ல இருந்து AI நம்ம மெடிசின்ல யூஸ் ஆயிட்டு இருக்கு. எங்க அப்படின்றத நம்ம ஃபியூச்சர்ல யோசிப்போம். அதுக்கு முன்னாடி ஒரு சின்ன வீடியோ.
பார்த்தீங்கன்னா இந்த ஃபிஃப்த் பேண்ட் வந்து குட்டியாக இருக்குது, நீங்கள் இதில் பார்த்தீங்கன்னாலும் சின்னதாக தான் இருக்குது, ரைட்? ஸோ கரஸ்பாண்டிங் இமேஜ் தான் உங்களுக்கு கிடைக்கும். தென் ஐம் கோயிங் டு as usual ஆட்டோமேட்டிக்காக லைன் செலக்ட் ஆகிடுச்சு. ஐம் கோயிங் டு மார்க் த பவுண்டரிஸ். Then I'm going to use the magic tool. 1, 2. நீங்க இந்த பவுண்டரி ஒழுங்கா லாக் பண்ணலன்னா என்ன நடக்கும் நான் காட்டுறேன். I will show you the example. 3, 4, 5, 6. So I got all the values. So fifth line வந்து comparatively low expression ஆச்சு. I also got the same expression. அதுதான் correspond பண்ணுது. So I'm going to copy. Control C கொடுத்தீங்கன்னா copy. ஸோ நார்மலைசேஷன் என்னன்னா நீங்க ஈக்குவல் லோடிங் காட்டுறேங்கிறதுக்காக இதை நார்மலைஸ் பண்ண போறீங்க. ஸோ நான் என்ன பண்ண போறேன், இந்த லைன் அப்படியே வச்சு அது மார்க்கெட்டையா லெட்ஸ் இது வந்து ஆக்டிவ் ஹவுஸ்கீப் இன்ஜின். ஸோ இதை நார்மலைஸ் பண்ணணும்னா இதால நான் இதை டிவைட் பண்ணணும். இந்த எக்ஸ்ப்ரோட்டினால இந்த ஆக்டிவை நான் டிவைட் பண்ணணும். ஸோ வாட் ஐம் கோயிங் டு டு இஸ் ஈக்குவல் this lane divided by this lane. So I am going to getting a value. The value when I எல்லா லேனுக்கும் செலக்ட் பண்ணிட்டேன், ரைட்? ஸோ இதை வந்து நான் எப்படி காட்ட போறேன்னா I am going to compare one value with other. For example, this is the first lane வச்சுட்டு மற்ற லேன் ஜாஸ்தியாக இருக்கா குறைஞ்சிருக்கான்னு கம்பேர் பண்ண போறேன். ஸோ அதுக்கு நான் என்ன பண்ண போறேன், I am going to divide with this layer with the same number 0.90. So I will get one full number. Okay. So இதை நான் drag பண்ணனா so இந்த values நீங்க செக் பண்ணீங்கன்னா first three lines are almost same there. So அதனால you get the same number. அடுத்த மூணு லைன் வந்து 0.5 ஒண்ணு விட 0.5 வந்துருக்கு, குறைஞ்சு வந்துருக்குன்னா அரை மடங்கு கம்மியாயிருக்கு, ஒரு மடங்கு கம்மியாயிருக்கு.
Small device. So that also it is a prototype also it was developed nowadays. Okay. So that also we have the Bigelonia systems and the Biopack system also. So Biopack is the where do I number one systems? What the purpose of number one? I'll tell you that. Okay. Yeah, it's almost 99% of using the top university in worldwide, and also they are using for IIT in our NIT and major institution. Everybody is using for the Biopack systems. For data collection, is a very poor quality of data. I'll show that what is the poor quality of data. You are saying poor quality. What is quality? So that's why I bring in the device. You can refer the live signals, okay, for the human subjects. Yeah. So this, so always you are telling is number one. Where have any proof? Yes, we have the proof of that number one system. It is from the 2017 onwards we are the number one, especially for the HAPS. You know the HAPS is HAPS member of the society. It's a human anatomy and physiology society. It starts from that. That's especially for doctors. Okay, this is a very good device. Yes, especially for advances technology. So from the bottom to top level, that means from the bottom is wired to wireless, and also even wireless, you don't need to carry your laptop and PC and things. Just we have the logger systems. Just you record your signal from the logger. We have the logger system, just like a mobile phone. Tap my signal. I want to record my ECG. Yes, it listens. Then you can record your signal live streaming. That also is possible. So this we can give to Indian Aerospace Medicine, especially for Sriharikota. Okay, that I will tell you the next things. Why I'm telling this things. Okay, next. Yeah. So our the companies, Gentech Marketing and Distribution Private Limited, we are on behalf of that. We are the main distributor in India. So nobody is there in India. We are the main distributor in India, sole authorized and a proprietary one. Okay. So you need any kind of research oriented, especially for education purpose as well as research kind of things and data collections. So it's used for carbon data. Okay. Yeah. So it started as a 1996 company. It's almost 2 decades was completed. So that's what we are go further. And come to our medical applications. So the medical application now we are all it was interconnected system. Okay. So in the human bodies it's connected. Every part is important things. We are not neglected. This is not important. This is not important. Never. It's everything is important. So you know very well about the people are how some of the things not there, but we have to practice.
Of course, you would have got it like this is a by reference. They said it by doing something. No, it's not. See, the reference is that you target one ministry of the department, for example, continuously apply. Okay, 10 times, 20 times, 30 times. The in charge of the scientist will be really watching your approach. Sometimes your budget is not choose, some other budget is not choose. Okay, this happens. And moreover, the way of writing is very important. Of course, right now only people understand that they talk some ChatGPT or something like that to write a paper. But already these things are there long before itself, but we are not aware. Correct? A lot of apps are there for research. Till now people are not aware of it. They compiled everything and they are given as a ChatGPT, but ChatGPT doesn't work very well. I don't know how many people have checked it. When you go for a link and you ask from them, already you are, what I can say, machine learning is there. Okay, bag of words, cloud of words, all this things. But when you do something with a new, polishing way, you feel that it is a very big thing. That is the problem with our professors. Already there. I am using long before these type of tools because I am into the academic writing, so I know that these things are very level. I will give a simple note that why you do a PhD for 6 years? Why you go and try to get your PhD in all other ways? Why you cannot able to do it? If you do your research on this, you get a lot of because I did it. My first thought was that why it takes 6 years? Why it takes 6 years? Why not university says 2 years or 3 years? And why people are doing for 6 years? And I found that keeping a committee of 3 or 4 members, student thinks that their idea is a valid idea, okay, and they say something. Student
famous that's called a 3D printer. The 3D printer actually is coming to the market in the year of 1980s, I think so, for the construction of the automobile, construction of some of the civil areas, buildings and all. Now it is entering into the healthcare in the name of bioprinting. And robotics technology, of course, we are all well known. Robotics technology play a main vital role in many sectors, particularly in automobile sector. But now, from 2011, I think so, there is a one robotic arm is there. Did the surgery also in America. Almost 1049 robotic surgeries are happened in US government, under the US government. But still it is not aware in India. The robots are used in healthcare but not going for the surgery sector. So this is what the technological development, and we can even take artificial intelligence. Artificial intelligence is concerned. There are so many programming, for example, the doctor's database, patient database, the imaging database, the signaling database, all these things are able to acquire and enable to save using the clouds by using the artificial technology, artificial intelligence technology, and then we can able to go for virtual reality. So whatever the technology is concerned, and ANSYS software from electrical, ANSYS software, they are going to use something for imaging in biomechanics sector in healthcare. So all these particular domains, totally 47 engineering domains are there in all over the world. We can able to connect 42 engineering domains with healthcare. So that is the reason why I am here. The biomedical technology, advanced biomedical technology is not individually framing. That particular biomedical technology is a group of all the other departments to come into play in the market, because vast of customers are there. Not only because biomedical is coming under the electronics and communication, of course, the people there, biomedical engineering, should know about the communication and should know about the electronics and electrical instrumentation and all. Without that, they are not able to deal with the instruments and all. And most important difference between the electronic communication and the biomedical engineers are, the customers are nothing but, they are all the highly graduated people are called the doctors. The doctors are the main customers for the biomedical engineers, because they are going to sell the product to the doctors. Almost 544 biomedical equipments are there in all over the world. None of the other domain having these much of the counts in their manufacturing sector. So all these 29,000 plus biomedical equipments are created, manufactured for diagnostic and therapeutic purpose of our human bodies. So because of the reason why the particular equipment are going to sell to the market through the doctors. Because of the particular equipment is making any fault, we need to make troubleshoot on it with the help of doctor's advice. So all these things we are going to connect the particular equipment to the customer through the doctors. So that is the reason why the differences between the electronic communication and your biomedical engineering is electronics communication. We have this variety of customers, but we have biomedical engineering have a single type of customers called the doctors, because equipments is getting to the hospital. That is an area, that is an atmosphere where the healthcare equipments are available, and we can able to connect all these equipment through the doctors. So that is what the anatomy is much required, because we are not supposed to sell the, for example, it is an ECG machine. We are not supposed to sell the particular ECG machine to the doctor in the way of electrical knowledge or electrical knowledge. We can't able to say, sir, this particular ECG machine consume 1.5 voltage, sir, here in this, these kind of the resistors are there, these kind of the transformers are there, we can able to adjust these signals and amplitude, all these kind of the words, doctor doesn't know about it. So we can able to sell that particular machine to the doctor through the anatomically. So using this particular machine, we can easily identify the defibrillation rate. We can able to identify the polarization filtration rate. All these anatomical values, anatomical words and technologies we must know. That is what makes the difference between the electronics communication people and the biomedical engineering. So once the technologies keep on moving, the doctors are also advised to learn about the technology, that is using of all the biomedical equipment. You know, in our incorporation, some of the doctors are also coming and getting a training, the basic trainings. For example, most of the doctors from the clinics, they're having a dental labs, they're having an ECG lab, they're having an orthopedics lab in their clinics. They must get certifications from any of the training institute. That is what advice actually come from many of the government in India, many of the state government from India, especially Telangana, Andhra Pradesh, they keep on following to this. So that is the reason why all the other, at the same time when the job is concerned, what all the domains.
The ventilators in Bangalore, okay, and it's supplied to all government hospitals. Like that, private hospitals also procure lot of private manufactured ventilators in lockdown time. But none of the ventilator produced is being checked properly before putting it use to the patient. Because it is an emergency, just it has to take to the patient. Just they produce without any passing any of the quality certification. The product directly taken from there to the patient. Now tell me, today's scenario, that particular all ventilator nearby 40,000 plus even private hospitals supplied particular ventilators are lying in the godown, not at all used on the patient. Because of that, the quality of the equipment is not being passed. Okay, so today's topic is telling you the gap between the production. Okay, that is the topic. Basically, this importance of testing and calibration of medical device is bridging the gap between the production department, whoever produced the medical equipment, and the hospital end user. Okay, so that only I am going to focus. Right. So you might have studied biomedical instrumentation, diagnostic and therapeutic equipment. This subject you studied, right? So out of that, which equipment you felt it is like more easy to learn, or which equipment you felt it is more difficult to learn in this subject? ECG you felt easy, okay? ECG felt easy. Actually, you have come to the right point. ECG felt easy. Can anybody imagine the block diagram of, imagine, I don't want answers, imagine the block diagram of ECG. So first it will be a power supply, EV supply, then some sensor, controller, A to D controller. Then have you heard about one particular block diagram called calibration in the ECG diagram? That calibration, one block diagram, one square was there, which says only one line, which Kanpur book I studied, which is there, only one line. Upon pressing the calibration button, 1 milliwatt will be adjusted. Like that, one line only is written in that book. Entire book regarding calibration, only one line is written, related to the ECG block diagram only. That particular line only is feeding me daily, because that is our product line. Okay, calibration is the field. In every medical equipment, if you take, like you said ECG, but let's take defibrillator. When you switch on the defibrillator, like called biosig, right? So it means system is booting up, right? Ventilator is booting up, diaphragm is booting up and coming to a particular screen now. So it means internally it does then some correction and it will come to your screen and stand. That is called as internal BIOS setup calibration. But here we are not talking about that particular calibration. Here we are talking about actual verification of the output which is going to the patient. Example, the entire hospital, now you know the classification of medical device, like
so here the sharing of information. So both sender and receiver, both of the same locations, we can just have the sharing of information just face to face. But if you just want the sender or resource may be in the different locations, so how can we just share the information? To transmitter and receiver, right? Any other mode of methods? Okay, someone just needs to carry your messages from one location to other locations. So with the help of networking, we are just sharing this information. Networking is here, it's interconnecting of two or more than two communicating devices, right? Which just carries your information from one location to other locations. So again, see in the networking, so we need a specific devices to share your information. That specific device, what we call it as actually telecommunicating devices. So generally the sharing of information is local, we can say it's face to face. If it is for remote, we can say it is a distance communication or the telecommunication. Tele, it's a Greek word which means a distance, right? So just sharing this communications, we need a specific devices, what we call it as.
So any size, do you have notebook or some other things? So you take your notebook, just draw a small square.
your choice case, you have to divide that square into 4 equal parts. That is very. So equal areas la irukano. Any shapes vandu any shapes, but they should be equal area wise. They are equal. So this is the common methodology. This.
Coordinator and the entire team. Okay, and you let know some areas of improvement. Yes.
On the biomedical signal processing using artificial intelligence, the keynote speakers from various places, they have given excellent lecture for us, who are all very new to this area. We learned a lot from the keynote speakers. Then the negative point, we are all coming from the long way to here. So the morning breakfast, if this, FDP means they have to provide. So that is one thing.
When is the program starts?
17 to 20.
Morning.
Morning
9:30.
9:30. If we miss the bus, it's difficult to reach this point.
Okay. Suppose